last time I think I left off telling you a bit about thyroid function and control. And so let me pick up the slideshow at that point. This is, by the way, the basic hypothalamic function. It's the second version of it. I think it's number 2 in the PowerPoint presentation. So slideshow. First slide. And last time I told you that this particular image is taken in a population that has iodine deficiency in the diet. The thyroid can't make thyroid hormone. You've broken the normal negative feedback onto the production of TSH in the pituitary and TRH in the hypothalamus, and thus they continue to put out more TRH, more TSH, and it's a trophic hormone, thyrotropic hormone. You'll find a lot of the hormones are called trophic hormones, and so it continues to stimulate the tissue to grow and cells to multiply and to attempt to make thyroid hormone. But because it's lacking a key ingredient in making that thyroid hormone, iodine, you end up with a condition like this. That's a non-functional goiter. I also mentioned the fact that there are functional goiters. In autoimmune conditions, you can get a situation where there's an antibody made by your immune system that stimulates the thyroid cells to make TRA, to make T3 and T4, thyroxine and triiodothyronine, and essentially takes the place of TSH. But because it's not under feedback control, the normal feedback controls anyway, you're going to get a situation where you suppressed TRH and TSH. Those levels are going to be low. Thyroid levels are going to be high because you've got the antibody stimulating this tissue. It's going to look like this, but it's going to be a functional goiter. It's going to be functional in making the hormone that tissue normally makes. Okay, now let's go on. So this is the next loop I wanted to pick up, and that's the control of ACTH, adrenocorticotropic hormone, which is going to stimulate, normally it's going to stimulate the outer layers of the adrenal gland, the ones that make steroids, particularly corticosteroids. And those steroids negatively feed back on the production of corticotropin-releasing hormone in the hypothalamus. So that's kind of the primary loop that you've got going on there. But superimposed on it are secondary controls, one of which arises in the immune system via the production of interleukins, like interleukin-1 beta, which stimulate production of CRH. Or you have vasopressin and other stressors. Stressors can be infection, so you can get involvement in the immune system there as well. But you can have emotional stressors, food stressors, heat stressors, any kinds of stress you can imagine. The signals coming from the central nervous system down through the thalamus, the amygdala area, and into the hypothalamus can all, again, affect CRH production and ultimately ACTH and glucocorticoid production. So if you're under stress, one of the things that happens when you're under prolonged stress? Happens all the time for students coming up to finals week. What happens? You get sick. Why do you get sick? Because your immune system is suppressed. Now you can see why your immune system is suppressed. Okay? That stress affecting CRH, ACTH production is going to increase the amount of glucocorticoid, which suppresses the immune system. Okay? So if you're sophisticated and you want to complain about the stress, tell them that you're disrupting your immune system, you're disrupting your endocrine system. Yeah.
The glucocorticoids suppress the immune system?
Correct.
Okay.
How so? Are we supposed to know
That glucocorticoids act via their receptors, which are found in virtually all cells, including immune cells. And in immune cells, it tends to turn off production of the cytokines, chemokines, and cell division, all those sorts of things that tend to be acting to counter pathogens.
But that's only at really high glucocorticoid levels.
It's at reasonably high, it's physiologically high levels. You don't have to be taking prednisone to suppress your immune system. Okay. This illustrates the problems you get with perturbations of adrenal function in terms of underproduction or overproduction. Overproduction, you've got something called Cushing's syndrome. Cushing's syndrome, although it's pictured for humans, occurs in dogs and horses and just about every other animal, along with primates. And the symptoms are shown here. The buffalo hump has to do with fat deposition, which is a problem that arises with perturbed glucose and fat metabolism. Thinning of the skin, that's cell multiplication. Thin arms and legs and muscle wasting. So it's a condition that can mimic diabetes in many ways. Also poor wound healing, easy bruising. All those look an awful lot like what you get with diabetes. Okay. Avascular necrosis of the femoral head, meaning you're going to get breaks in the legs or in the limbs on falls. Increased abdominal fat, again related to fat deposition problems, glucose metabolism. The moon face with red plethoric cheeks. Anybody who's on glucocortical steroids like prednisone, what are a couple of things that happen? Anybody who's taken them? You get swelling, you get edema. In lots of places, the place it looks at where you'll see it first is in the face. You also get problems with fat or weight gain associated with fat deposition. Okay. Cataracts, again, something that looks an awful lot like what you see with diabetes and problems with glucose metabolism.
What are cataracts?
Cataracts are clouding of the corneas in the eye. Okay, they can lead to blindness. If you live long enough, you'll probably end up with cataracts. Something like 70 to 80% of the older population have them at some degree or another. Yeah.
And Cushing's syndrome comes from hyperfunction?
Yeah, it's overproduction of glucocorticoids. The hypertension is an interesting one, which is related to problems in water metabolism and sodium retention. You'll find out later that there's an overlap in glucocorticoid action and aldosterone action, which is mineralocorticoid controls on sodium retention. So when glucocorticoid levels are high, there's a crossover into mineralocorticoid controls. Yeah?
The list of symptoms right there, are those more symptoms from Cushing's syndrome?
Down here?
Yeah.
Yes. So osteoporosis, thinning of the bones, tendency to hyperglycemia, overproduction, or high levels of glucose in blood, negative nitrogen balance goes with wasting, muscle wasting. That again is a problem that looks like a lot like diabetes. Increased appetite, Again, in a diabetic condition, people will tend to eat a lot more, but they don't derive the nutrition from the diet because they can't absorb glucose properly. Is there a question over here? You were just drinking. Okay. Okay. Increased susceptibility to infection. We mentioned that, and obesity. All right. So that's what happens for things that will tend to stimulate or overstimulate the adrenal cortex. Well, how do you get overstimulation? How many ways can I get overstimulation of the adrenal cortex? I showed you a loop, control loop. How many ways? Let's go back to that control loop. There's a control loop. How many ways can I get overproduction of glucocorticosteroids?
5.
4.
Don't give me a number. Tell me where they are.
So
What will cause overstimulation?
Any of those
Okay, a lack of negative feedback to the hypothalamus. So there could be a problem with the receptor for glucocorticosteroids. That's one. What else?
Can it be like any of those green stressors if a lot of that is going on?
Any of those things can generate overproduction of CRH. Anything else that's going to cause overproduction of steroids? So we've got at least 2 or 3 possibilities there. Anything else? How many hormones are involved? We've got CRH, we've got ACTH, we've got the glucocorticosteroids. That's 3 hormones. How do those hormones act? You learned this in the last exam, hopefully.
They're all positive.
No, it has nothing to do with being positive.
G-protein coupled receptors?
No, they don't have to have the G-protein coupled receptors. But what do they have to have?
Receptors.
Receptors. They have to have active receptors. So if there's anything wrong with any of the 3 hormone receptors, you have the possibility for overproduction of glucocorticosteroids. You mentioned transduction factors. Do all the receptors have transduction factors that are G proteins?
No, but glucocorticoids do.
No, they don't. Glucocorticoids do not.
GR can act as a transcription factor.
It can act as a transcription factor with its receptor. Okay? And it is a nuclear receptor. It's inside the cell.
And it can translocate.
It translocates to the nucleus, where it acts on DNA. It does not interact with G proteins directly.